Hi, this is Stephen, and in this video we will discuss how to use the conservation of flow or conservation of mass to quantify mitral regurgitation. And so let's start with our apical four-chamber view. We have the left atrium that empties blood into the left ventricle, and we tip our probe so that we can see. That's right ventricle, right atrium. We tip our probe so that we can also see the LVOT and aortic valve. And shade in some of this here. And if we have mitral regurgitation, there's a couple different things going on. So first we have blood coming in here via the mitral valve, filling the left ventricle. But then we have some blood that is actually leaking backwards. I've drawn it a little bit off center, but this yellow indicates blood that is leaking backwards, mitral regurgitation, and then we have blood that is leaving the aortic valve over here. How can we use the conservation of mass or flow to solve for the mitral regurgitation flow? Well, basically, if you look at the left ventricle, whatever comes in has to come out. And so if I write that in equation format, I would say that the blood that comes into the left ventricle, that red arrow, equals the sum of all the blood that is leaving the left ventricle, whether it's leaving through mitral regurgitation or whether it is leaving through the proper way, the aortic valve. All right, how can we figure that out with some math? Well, we will need to take, let me get a different color here. We will need to take, in this purple, we're going to measure the velocity with pulse wave Doppler. We're going to measure it right here for mitral inflow and outflow, and we're also going to take it and measure it right at the LVOT right there. And what will we get? We'll get a couple different graphs. So at the mitral valve, we'll see a signal like this. And this is the inflow. This is blood coming into the left ventricle. You'll note it, unlike the aortic valve, it's two different peaks. There's the E wave and the A wave, and we'll take the area right under here to get a VTI. Let's say that that is 12 centimeters. That's our VTI. I didn't draw the regurgitant flow here. We're just focusing on the inflow from this trace. And then let's look over here at the aortic valve, and we're going to see during systole that there's blood that is getting pumped out. And if we were to take that area, let's say that we got a VTI of 20. 20 centimeters is the area under this curve. How do we use this to solve for our unknowns? Well, we'll try and stay organized with the different colors, but if you have the flow, so let me see. If we have the flow through the aortic valve, and if we have the flow that is leaking backwards through the mitral valve, that should be equal to the flow that is coming in from the mitral valve. So in equation format, that will look something like this. We can say pi times, now we'll need the diameter of our, we'll need two different diameters. I'm going to do a separate drawing to show you where we're getting those from. So from our parasternal long, RV up there, we can get the dimensions of our LVOT, which will say that that diameter, if that's 2, then the radius will be 1. And then actually from the apical four-chamber itself, we can get the dimensions right here. And let's say that that is 3. So the radius will be 1.5. So now, knowing that our equation is pi r squared times TVI, that gives us the flow for each of these arrows. We can say that pi, What's the radius of our mitral valve? Well, that'll be 3 over 2 pi r squared times 12. And now we're trying to solve for the yellow arrow, so I'm going to say minus pi. So this is the blood flow that is going out of the aortic valve. Pi times 1 squared times 20. This is going to be equal to r equals our downward arrow, or the amount of blood that is leaking backwards, the mitral regurgitation. When we plug in some numbers, we'll get that the mitral regurgitation equals about 22 milliliters, which would be in the mild range. So again, a couple different steps here, but I want to emphasize that all we did is we said conservation of mass and flow implies that whatever comes into the LV, the red arrow, has to be equal to whatever leaves the LV, whether it's leaving appropriately, the green arrow, through the aortic valve, or whether it's leaving inappropriately, mitral regurgitation, with the yellow arrow. Then, for our two known arrows, we took the dimensions from various echo views, along with the TVI, to figure out what that actual flow was. So we have our red arrow of flow, we have our green arrow of flow, and then we were able to solve for the one unknown, which is our leaking mitral regurgitation, or the yellow arrow, which was 22 mils in this case.